Welcome to video 16 on conservation of energy. The essential question we are going to be answering in this video is how and why does energy move around in systems? So one of the big ideas in this unit is that energy is one of those properties that is conserved in a closed system, meaning it cannot be created or destroyed. Instead, energy can be transformed from one type of energy to another, like the types that we talked about in the previous video, or transferred from one object to another. In fact, all energy that we have can be traced back to the Big Bang. Energy has been transferring from one object to another ever since the beginning of our universe with the Big Bang. 13 billion years ago. So, for example, if you have a light in your room and it's turned on, there is light energy shining on you from the lamp. That energy is being transferred to the lamp as electrical energy from the socket. And the electrical energy that's going to the socket is coming, if you live in the Pacific Northwest, from the motion of water flowing through a dam, most likely. The motion energy from that water starts off way high up in the sky as water in the atmosphere, so it has gravitational energy. And in order to get up into the atmosphere, thermal energy had to warm up a body of water like a lake or the ocean. That thermal energy has been transferred to the object in the form from sunlight, from light energy, and that energy originated as nuclear energy coming out of the sun, as nuclear fission is occurring inside the sun's core. The sun's core got its energy from all these tiny particles of gases and space dust that pulled together with gravitational energy throughout space to form the sun. And before that, you had the Big Bang and all the motion that expelled. Energy can also be transformed from one type into another. This can be within a single object, or it can be within a system of objects. So if we look at these skydivers here on the left, they're starting with lots of gravitational energy. They're up high in the sky, and as they fall, that gravitational energy gets converted into energy of motion. This little girl on the right is in some big inflatable ball, and she has a bunch of chemical energy from eating a good lunch, and as she moves through this ball, she's converting or transforming the chemical energy that she's got into rotational energy as this ball rolls. In almost all scenarios, other types of energy are also generated as waste energy. You can often identify types of waste energies if you hear sound or you feel heat. Sound is wave energy, so if you're hearing a noise, and heat energy is from friction, is a type of thermal energy. So with the skydivers here, as they fall through the atmosphere, there's definitely friction as they move through the air between the air molecules on their bodies. So one of the types of waste energy that they're probably generating is thermal energy. Energy bar charts are a nifty tool to help you keep track of the different energy types in your system, how that energy transfers from object to object, and how it transforms into different kinds of energy. So in the first picture here, we have a little boy and girl, and they are about to head up a hill. So they have chemical energy stored in their bodies. When they get to the top of this hill, they have gravitational potential energy because they are up high. They started low and they've moved up high. So their chemical energy was transformed into gravitational energy. And in the meantime, they also generated some waste energy that was from wave, because they probably made some noise, and also probably lost or created some thermal energy. In the last picture, all the way on the right, you can see the two of them falling down the hill. So their gravitational energy that they had at the top of the hill was being transformed into motion as they fall, and some more waste energies are generated, such as wave and thermal. If we take those energy types that we identified in the previous slide and we display them as a bar chart, we can start to keep track of how energy transforms and transfers from one situation to the next. At the beginning of the climb, where the two kids are at the bottom of the hill, the majority of their energy is all chemical energy. So when we look down here, you can see that the kids have 10,000 joules of energy, and the gray bar represents the sigma E, or the sum of all the energy in that system. So this shows us that the sum of all the energy in that system, it's all chemical energy. We know it's chemical energy because it's the energy they have stored in their bodies getting ready to do something. Now in the middle picture, when they've gotten to the top of the hill, that chemical energy that they had has been transformed into gravitational potential energy. So we've got this blue indicates gravitational energy, and the chemical energy that we started with is now divided into 8,000 joules of gravitational, and 2,000 joules have been turned into waste, which could be either through wave energy or thermal energy. But you'll notice for the final sigma E bar, the last gray bar all the way on the right, the total still adds up to the total before. So the total at the beginning of the climb is the same as the total in the middle of the climb. It's just distributed between two different types of energy. When the kids are tumbling down the hill, again, you'll notice that the sigma E, or the sum of the energy, is the same over here as it has been all along. We still have 10,000 joules of energy in our system. However, that energy has transformed once again, and instead of gravitational potential, that energy is turning into energy of motion, as you can see with the red colored bar. So we've got energy of motion because those kids are rolling, and there's lots of waste energy there. You've got a larger yellow bar, so probably lots of thermal and wave energy as those kids are bumping along the ground. Friction with the ground, adding to the thermal, and probably lots of complaining. There's a little bit of gravitational energy left, and that shows us they are not quite at the bottom of the hill. They have still a distance to fall. But from the beginning to the middle to the end, the sigma E is the same each time because energy is conserved. But sometimes it gets transferred and transformed into different types. Let's revisit our essential question that we started the video with. How and why does energy move around in systems? And we'd like to you to take a couple of minutes to write a few sentences summarizing the answer to this question. So in your summary, make sure to include some information on transfers and transformations, and use the words conservation of energy somewhere in there.